All right, here we are. We're all the way to number 6. This is great. We're on the Intro to Vectors worksheet. We're on number 6. One nice thing that's going to happen here is we're going to switch out of doing force vectors and think about some speed vectors. But everything's the same. We still work the same. Here's the question. We're in a raft. We're sort of lost at sea. And so you're sitting out there on this raft and you decide that you're going to paddle 5 kilometers an hour, and you point the raft directly north and you start paddling away, and that's how fast you can paddle is 5 kilometers per hour, and you're pointed north. So I've shown that with this vector here. We have a vector pointing north, magnitude of 5, so length here is 5, and our unit's kilometers per hour. But the same thing's happening at the same time. We have a wind, and that wind is pushing you west at 2 kilometers an hour. And so I'm showing that with a little vector here, showing the 2 kilometer west due to the wind. And those are nice vectors to deal with because they're on the compass lines of northeast by south. Unfortunately, the water current, which is going 4 kilometers per hour, is off at an angle. It's at 30 degrees south of west. And when we have that red vector here that's 4 long and off at 30 degrees south of west, it's really hard to work with that number because it's at an angle. And what we really want are vectors that are on compass headings, the way this one is and this one is. So we don't want to work with that 4, but we need to use it. We need that information because that's what the current is actually doing. So what we do is we get the components of the current, and then we'll have 2 vectors instead of 1, but they'll be on the compass lines, which is much easier to work with. So this is what we did early on in the worksheet. I think back on number 2, we looked at, okay, well, how do I take a vector and get its components? And so here we have this 4 at 30 degrees. And so we know that the sine is the opposite over the hypotenuse. And so if we do 4 sine 30, we would get a 2. We know that this one, the west one, would be the cosine because it's the adjacent. And so here we go 4 cosine 30 to get our 3.46 to the west. And after doing that, we're going to use these blue vectors instead of the 4 vector when we're thinking about what's going on in the problem. So we have these 3 vectors, which we've now turned into 4 vectors instead, not going to use the 4. And we're going to add them all up because all of these things are acting on the raft. Right? We're going north because of the paddling, we're going west because of the wind, and then the current is doing both another west and a south. And these 3 vectors add together to say where we're actually going, what direction and magnitude if we were asked how fast we were going. So here's what we do. We're going to take these vectors and we're going to add them up. So 2 to the west and 3.46 to the west give us 5.46 to the west in green here. Okay, that was easy. This didn't have any west. And this one over here, right, this had west only. This had west only. We're going to ignoring the 2 because it's a north-south. We're not using the 5 because it's a north-south. We're only using this 2 and this 3.46. which add up to 5.46. So that's where this green vector going west is coming from. North and south, let's see, we've got a 5 going north, which is canceled somewhat by the 2 going south to leave us with 3 going north. So overall, we end up going north at 3, and we go west at 5.46. And those 2 vectors we can add together like we did back in number 2 to come up with the overall vector. Notice we didn't use that 4, right? It's a common mistake is to think you have to use that 4, but we're using the components instead of the 4. Anyway, so we can get that angle using an arctangent of 3 over 5.46, and that angle is going to be from the west, so that's going to be north of west at 28.8 degrees. And we can do Pythagorean theorem to get the speed, 6.2 kilometers per hour. I don't think I asked for that. I think I just asked for the angle. But in any case, that's how you do number 6. Good job.